It is stack and heap. Okay. So people who actually know or have heard about stack, those who have learned about DSA or data structures for enthusiasts, or even for those who are learning C programming or Python, anything, you might have heard of stack. Stack is basically an LIFO data structure. Okay. LIFO means last in, first out. So what has been sent the last would be the first one to be accessed from a stack. Okay. Now you might have heard of stack, and you might, if you know threading or multi-threading, then you know that different threads are placed in different stacks. Okay. Now there are two operations possible with stack, that is the push and the pop. Push means to push into the stack or to insert an element into the stack, whereas pop means to take out an element from the stack. Okay. Now, data with unknown size at compile time or size that might change must be stored on the heap. Now, this is the case. Okay. So we have two different kinds of data types. Now, the one whose size is actually known at compile time. So the good examples are I32, F64, F32. We actually know, like, okay, this is going to be 32-bit. So we can allocate the required amount of space as we during the compile time. But this is not the case with string. This is not the case with struct and etc. because we might have some data structures which may be growing. For example, vector is a dynamic array which can grow. String can also grow when you can actually add or push stuff in the string. Okay. So in these kinds of data structure, we need to keep them in the heap instead rather than keeping them in the stack memory. Okay. So there are two different kinds of data types whose size is known at compile time, which is placed in stack, whose size is not known at compile time is placed in heap. Okay, we talk about something called as copy trait. Now, copy trait is a particular kind of trait that we implement for those data structures whose size is actually not known at compile time. And these things or these structures, for them, the copy trait is not implemented, and for those whose size is known, like I32 F64, these things have its copy trait implemented already. So once the copy trait is implemented, that means we can move a variable's value to another variable, and this would be like creating copies. So when you just create a variable x and then you pass its value to y, then both x and y will contain the same value. Okay, so for those structures whose copy type is implemented, and those are those structures which whose size is known at compile time. Okay, so these things like I32 F64, the copy trait is already implemented, but for string and other data structures, they are not implemented. The first question is stack is a dash data structure. Okay, the options are LIFO, FIFO, array, hash map. The second question is state whether true or false. Copy trait is implemented for string. The options are true and false. Yeah, so the first question was stack is a dash data structure, and the answer is LIFO. State whether true or false copy trait is implemented for string. The answer was false. That means copy trait is not implemented for string. That's what I was trying to convey. That copy trait is only implemented for those data structures whose size is known at compile time. Okay, we'll talk about ownership rules and scope of variable. Okay, so you might have heard of this word on a scope. So what is scope? Scope means the area or the definition or the area where its value is actually pertained. So when you create a wrapper, like the opening and closing brackets, and then you place let x equal to 25. Yesterday, not yesterday, I think on the 11th, I've already shown you an example of shadowing. Shadowing is actually a part of the scope variable. Okay, basically what happens is when you create a wrapper and when you define a variable inside a wrapper, its scope only exists inside that wrapper, okay, or that block. Now this particular kind of value cannot be accessed outside the scope. Okay, outside the scope means outside the block you cannot access it. So when x comes into scope, it is valid, and it remains valid until it goes out of scope. Okay.